This is our paper as the project of the student with the title Selection of Human Resource Prospective Student using SAW and AHP methods. We already know that SAW is a simple additive weighting and AHP as an analytical hierarchy process method. The student that part of this project is Ahmad Rufai and Diana Teresias Warner, and they are from Information System Department, School of Information System, Bina Nusantara University. Me, myself, Harko Leslie Henry Warner. I am from Computer Science Department, graduate program, Doctor of Computer Science, Bina Nusantara University. And we have a collaboration with Professor Anthony Doucet from Laboratory L3E, University de La Rochelle, France. So today we would like to discuss about our paper. As you already know, the role of human resource HR in an organization is significant, and the role of the word education plays an essential role in producing and educating qualified human resource. So in this paper, we try to use as an example 20 students were evaluated as learning with simple additive weight or SEW and analytical hierarchy process HEP, which apply 6 criteria such as experience, recommendation, interview, discipline, skills, and physical health. The SAW and HEP method are techniques for determining the best value from several predetermined criteria so that they are suitable for use in the selection of HR candidates the company will accept or the schools. The results show that consistency similarity between SAW and HEP method had a score of 7 plus 8 divided 20, so 0.75, or similarity consistency index of 75%. The similarity consistency of index is evaluated using the same ranks order and the opposite with reversal. So looking at this problem, the role of human resource or HR division is considered to be the yet maximally handling the problem of selecting human resource. Selecting and receiving human resource is still not done professionally but using bribery, friendship, or family relation. This is happening because there is no human resource selection process with standard systematic method to assess the eligibility of prospective HR. Therefore, in overcoming the professional acceptance of human resource, the role of the human resource or HR division is to establish cooperation with educational institution or school. The company in parts of Department of Human Resource Division surrounded fully to educational institution or school to select quality prospective human resource student in this collaboration. Based on the background of the problem outlined above, several problems can be formulated, namely, number one, how is decision support system for selecting prospective HR student using SAW and HAP method? Regarding with the calculation process, which method is easy to understand and is more suitable for selecting HR candidates? From the side of final result obtained, which method is more accurate? It is necessary to limit the practical problem so that the problem is under study is straightforward and not complex. In this case, the restriction taken are research focus on selecting human resource candidate and the final result of the method calculation. And the example of application are carried out to evaluate the selection of 20 prospective human resource students. In order to try to implement these kinds of implementation, we first try to implement simple additive weighting SAW method. So in this, our paper, SAW method has 4 steps, such as number 1, list of weighting criteria, including the range of criteria, and normalization of criteria range. Number 2, scoring of sample data using normalized range of criteria. Number 3, normalization of performance rating score. Number 4, ranking scores. So in this case, we try to, this is the first step. We try to list all the weighting criteria. So like I mentioned before, we have 6 criteria such as experience, recommendation, interview, skill, physical health, disciplines. And we try to give the weight for explain 5%, 20%, 10%, 10%, 25, yeah. And the rank criteria, this is because of the currents, yeah, the currents of criteria. So in this case, we try to make the normalize of the criteria with 1 to 1, 4, 1, 5, yeah. This is based on parts of the 1 or 2 become with or without, yeah. And 1 until 4 become for the recommendation, minor, adequate, very adequate, substantial. For the criteria interview has very bad, bad, adequate, good, very good. Yeah. The criteria for discipline, deficient, adequate, good, very good. The criteria for skill have optional such as bad, deficient, adequate, passable, good, very good. Yeah. The criteria for physical health are bad, deficient, satisfied, and very satisfied. So this is the first step in order to try to list the weighting criteria, rank criteria, normalization. Yeah. And then we have step number 2. This is scoring and sample data using normalized ranks of criteria. So the scoring student data will be matched with the last column in the table 1. So in this case, because we have already 20 students, so we try to mix the scoring data. Yeah. So the next table here showing the result of 20 student scoring. Yeah. Then we have step number 3, normalization of performance rating scores. Yeah. So it's the scores based on the previous table 2. We try to apply with the formula 1 here. Yeah, the first formula here where the equation such as x, y, z divided with max x, y, z if attribute is benefit, and if attribute j is cost, then minimum x, y, z we divide with x, y, z. Yeah. So in this case, we try to using the x, y, z divided max. So this is become benefit. Yeah. So this is the explanation. RIG is the normalized performance rating score. XIG is the weighting criteria score. Max SIG is the highest weighting criteria score. Minimum XIG is the lowest weighting criteria score. Yeah. E is an alternative as a student. Yeah. J is a criteria. Yeah. So in this case, for example, where E and J 1 to 6, yeah, then RIG as the first RIG because R11, so we have to get the data from the previous table. We got 2 divided 2 become 1, yeah, this is 1, yeah. And then the R12, 1 divided 4 or 0.25, this is 0.25, yeah. And REG R13 to divided 5 or 0.4, so this is 0.4, yeah, and etc. Yeah. So we can see in the table here, show the result implementation with equation 1 here, yeah, with the score 1 or 0, 1 or 0.5 or 0.5, yeah. And then we have the fourth step. This is the ranking score. So we have to apply these equations, yeah. Phi I as a ranking for each alternative student, and we have WG, the weight score for each criteria, RIG as a normalized performance ranking value, E as an alternative for student, J is a criteria. We look at here, then each of the limitation, WG is criteria weight seen in the third column in the table 1. Yeah. So there is a weighting score such as 0.05, 20%, 10%, 10%, etc. Yeah. So if you look at this first line in table 3, yeah, so for the fee, we have to refer to the previous table for the each numbering, and then we got each the number will multiply, yeah, with the weighting score such as 0.05 like here, yeah, and with 0.2, yeah, 0.1, etc. And then we got the score here, yeah, as the 0, 0.5, 0, 0.5, 0, 0.4, etc. And we got 0.49 here. So the fees become 449. The same as well with the other score as well for other students. So after that, we got, of course, based on the result in the table 3, we can try to make the ranking, yeah, for the results of the students, yeah. And in this case, we got scoring for the students such as ranking. This become normalized metric, yeah. So the first ranking is for the student number 20, yeah, student 20, and the last ranking will come to the student 18, yeah. So this is because the more higher the fee scores, it's become the highest scores, yeah. So the more lowest score, so this is become the more lowest ranking order. So after we get the SAW, simple additive weighting, so we try to apply with the analytical hierarchy process or HUP implementation. So in this case, we try to apply the HUP method with two steps, such as the first processing criteria and the second one processing alternatives. In the step 1, the processing criteria has 3 sub-steps, such as pairwise comparison metric, normalized pairwise comparison metric, and calculating the consistency. And in order to try to apply with the step 1A, yeah, pairwise comparison metric, we try to apply with this equation number 3 here. So in this equation number 3, row and column number, in table 4 will be try to apply, yeah. We divided each of them, 0, 0, 0.5 divided with 0, 0, 0.5. So we got 1 here, and 0, 0.5 divided by 0.2 become 0.25, etc. Yeah. So the last column in which we use for the next equation 3, row and column number are row and column number in table 4. Yeah. For example, they will divide it when we got the number of pairwise comparison metric for the criteria. We enter to the step 1B, yeah, as a normalized pairwise comparison metric, or PCM. Yeah. So in this case, we try to apply with 3 equations, such as normalized PCM, where the score will divide with some columns, yeah, as equation 4. Equation 5, criteria weights. Actually, equation 5 and 6, they are similar, but they have different how to apply for it. Yeah. For example, criteria weight for the equation 5, they average some row scores here, and criteria weight will they try to using the eigenvalue and multiply with 1 divided n, yeah, and we multiply with some EV. So in order to try to normalize pairwise comparison metric, yeah, we try to apply with the example in table eigenvalue 1, the multiply 0.25, 0.5, 0.5, etc. And we got 0.0021 using equation 6. Then eigenvalue power, or power 1 divided n, multiply with some eigenvalue number criteria 6. Yeah. So after all the criteria had found the eigenvalue, yeah, the sum eigenvalue is 7.146, yeah, as shown in the last column eigenvalue. Then, for example, the first row has a criteria weight, yeah, 0.0 as the value in the first row in column criteria weights in the table 6. And this is the step 1C, yeah. So the third step in the first step, yeah. In this case, we try to apply 5 equations, or 6, sorry, yeah. Weighted sum value, where they will try to sum the row scores, yeah. And we have criteria weight, yeah. Eigenvalue will power with 1 divided n, and ratio weighted sum value divided with criteria weight, yeah. And we have lambda maximum, yeah, where this got the average ratio. So this is the implementation using eigenvalue or the same row for the example, yeah. And then the eigenvalue power with the 1 divided n, yeah. So we got 0.05, yeah. And of course, after that, we got the equation 9 here by dividing the weighting sum value with character weight. So we got the lambda maximum max, yeah. And the second step, yeah, we have a second step when they have a subset such as pairwise comparison metric and normalized pairwise comparison metric. Yeah. So in this pairwise comparison metric, for alternate grades based on 20 student assessment data in table 2, where each student has weighting criteria and each PCM will be scored based on each criterion, where in this paper there are 6 criteria. Yeah. So there will be 6 tables like table 8, yeah, as we'll mention in our paper. Yeah. Show the PCM alternative as experience criteria on the table 2. Attribute S1 to S2 in table represent student 1 to student 2. Yeah. And the second sub-step, normalize pairwise comparison. Yeah. This will be done using equation 4 by defining its score. Normalize where the score is some correlation since they are key number criteria such as key until key 6. Yeah. Then same like PCM has 6 table. Yeah. So this is the result of the implementation of HEP, yeah, method. Yeah. It's already mentioned here, and then we have a total eigenvector here. So we got the ranking factor for the results. Yeah. And so the total eigenvector, we have the highest score for the student, the same as well like SAW. This is a student 20 as well. Yeah. They got the high scores. Yeah. And then the lowest score will become to the student number 18, yeah, with the score 0.02, yeah. So this is more similar, yeah. So this is the difference between the student SAW versus AHP, yeah. If you look at here, then there will be a similar thing, yeah, when we can see there is a similar between the number of ranking high score and middle score. If you look at the first thing, the first number ones, yeah, for they have rank 1, they are the similar student 20 and student 20. And if we look at the ranking 20 will become to student 18, and they have also student 18, yeah. So if we look at here, there's some similar thing with the number for ranking number 1, ranking number 8, yeah, for ranking number 8 come to the student number 3, ranking number 13 come to the student number 19, ranking 14 come to the student number 1, yeah, and ranking number 19 come to the similar students, student 8 as well. And of course, if you look at, there is some similar with the yellow one. I give the box something like this, yeah. So this is, we look at here, there's some changing position here, the same 10 12, but the position in 6 7, yeah, the same as well with 4 student position 4 6 and 7. Okay, thank you for listening our presentation. See you again. Bye.